In this lesson, we're going to talk about compound inequalities. The essential understanding here is that a compound inequality consists of two distinct inequalities joined by the words and or the words or. So let me give you an example here in box number 1. Okay, so there's 4 examples. These are examples of compound inequalities. Notice down here I say x is greater than 2 and x is less than or equal to 6. This is a compound inequality because they are two distinct inequalities joined by the word and. So how would I graph that? Well, I want all numbers that are bigger than 2, so I would go up here and put an open dot around the 2, but less than or equal to the 6. So I want all of these numbers that are included in this line segment. Okay? Take a look at this one over here on the right. This one says x is less than or equal to 3, and at the same time x is greater than negative 4. This is another compound inequality because they're two inequalities joined by the word and. So how would we graph this? So I would go above 3, and I would go over above the negative 4, and I want all numbers that are less than or equal to 3, so I'm going to shade this direction, and I want numbers that are greater than negative 4, so notice I would shade that direction to the right. So I want all of this information here. You can kind of think of it as two inequalities put together, right? If I look at this one, I want all numbers that are less than or equal to 3. So that would be this one here by this green graph, and I would want that total direction. And then if I did, say, this one in purple, x is greater than negative 4, well, I would go here and I would shade this direction. And you can clearly see here that the overlap, right, the part that they overlap is the compound inequality part that we highlighted here in yellow. Okay? Here's another example. These ones are word or. So this is a compound inequality because it says that x is less than or equal to negative 1 or x is greater than 2. So this is going to give us a different type of graph. So let's go up to negative 1. Let's graph this one, less than or equal to negative 1. So I'd color that in, and I'd go to the left and shade all this stuff, okay? And then I'd go greater than 2. I'd go above 2, and I would shade to the right, all of this stuff. So notice that there's two distinct regions here for the OR graph, whereas for the AND graph, it was one little line segment. Okay, last example here. X is greater than 4, so again we have a compound inequality because I have two distinct inequalities joined together by the word or. So let's see here, go above 4, okay, and I want to shade to the right. Okay, and then let's go above the negative 2, and I would shade to the left. So this is another compound inequality. So notice the shapes that these take. Okay, and statements give me line segments, or statements give me two arrows going in opposite directions. That's going to be important for later. Box number 2, we have an example. We're going to write a compound inequality. Part A says all real numbers that are greater than negative 2 and at the same time less than 6. So here's what I want. Negative 2 and 6. These are my end caps, right? You can think of negative 2 is the smallest, 6 is the biggest. And I want all numbers in the middle. So I want negative 2 is going to be less than x, which is less than 6. So this right here is my compound inequality. I could write it a different way too. I could say all numbers that are greater than negative 2. So I would say x would be greater than negative 2. And this one would be all numbers that are less than 6. So it would be x is less than 6. So notice that if I switch this around to put my variable on the right-hand side, I would have negative 2 is less than x. And then this one says x, that same x is less than 6. Well, that just simplifies down to negative 2 less than x, less than 6. That's how I get that one. Notice it's the same thing. Okay, take a look at part B here. All real numbers that are less than 0. So x is going to be less than 0 or greater than all numbers that are greater than 5. So I would simply just say or x is greater than 5. So with an or statement, you actually just keep the word or in between. With an and statement, you put the x in the middle, like we've written here in example A. So box 3 is an example. The directions say to solve the compound inequality and graph the solutions. This is an example of an and compound inequality. So we solve this the same way that we solve regular inequalities. And here's how we would do it. So I want to isolate the m. So I'm going to add 4 everywhere I need to add the 4. So I'm adding it to on the left. So you can kind of think this and break this up into like 3 little places. So the left, the middle, and then the right. So if I take -3 and I add 4, of course we get 1. Okay, this is going to be less than or equal to m, which is now less than -1 plus 4 is 3. So there we go. There's my compound inequality, and it says to graph it. So I put my number line down, I put 0 over here, and I put 1, and then I put 3, because now I have 2 points in question. And then to graph, I would go above the 1, and then close the dot, go above the 3, keep it open, and I would want everything in the middle. And that's how we would graph the compound inequality. Box number 4 is a U-try. So I want you to do the same thing that we just did in box number 3 on your own. I want you to solve the compound inequality. You can graph the solution, but I won't ask you for the graph in the actual answer. Hopefully you got the right solution, but if not, here's how you would do it. I would add 4 here, I would add 4 to the left, and I would add 4 to the right. And I would do 3 almost little mini problems here. So -2 plus the 4 gives me 2. This is going to be less than 3y. This is going to be less than 14 plus the 4 gives me the 18. Now I need to get the y by itself, so I'm going to divide everything by 3. And I get this. I get 2/3 is less than y, which is less than 18 divided by 3 is 6. So the graph that you should have come up with on your own would have been 0 here, 2/3 here, 6 there, 2 open circles above, and we would shade the area in between 2/3 and 6. Box number 5 is solving a compound inequality involving an OR statement. So I have 2 different statements here. I have this statement here on the left, or this statement here on the right. So we're going to solve them both simultaneously and see what we come up with. So we solve them just like we would in the last section. So I'm going to subtract 2. Oh, that's a 3. Subtract 2 from both sides. So I get 3x is now less than -7 minus 2 is -9. I would divide by 3. I would divide by 3. And I would get x is now less than -3. Or, remember, we're going to solve these both at the same time. Over here I would subtract 5. And I would get -4x is less than 1 minus 5 is -4. And then I would divide by -4. And then I would reverse the direction of the inequality sign because I'm dividing by a negative, and I would get 1. So this is saying we want all numbers that are less than -3 or greater than 1. So if I was going to graph this on the number line, here's 0, here's 1, here's -3. So x is less than -3. So open dot, shade to the left. All this information here. 1, open dot, and shade to the right. All this shading here. Notice that because we had an OR statement, we get 2 separate arrows going in opposite directions for our answer. That will always happen when you're given an OR statement. Box number 6 is a U-try. So I want you to do the same thing that we did in box number 5. What are the solutions to the compound inequality? Oh, -2x plus 7. Not sure if you guys caught that one, but I forgot to put this part in here. So here's our first inequality. -2x plus 7 is less than 1, or our second inequality is 4x plus 3 is less than or equal to negative 5. Go ahead and try that one. Hopefully you got the right answer, but if not, here's how you do it. So I rewrote the problem again. Negative 2x plus 7 is less than 1, so I'm going to subtract 7 from both sides. Now we get negative 2x is now less than 1 minus 7 is negative 6. I would divide by negative 2, and I would reverse the direction of the inequality sign because I'm dividing by a negative. So I would get x is greater than 3, because negative 6 divided by 2 is positive 3. Or, the other one, I would subtract 3 from this side, and I would get 4x is now less than or equal to negative 8. I would divide by 4 on both sides, and I would get x is less than or equal to negative 2. So to graph this on the number line, I would put 0 here, I'd put negative 2 here, oh, not negative 20, negative 2, and I would put 3 over here. So I'd go above the 2, go circle it, shade it in, and go to the left. And then I would go above the 3, keep my dot open, and shade to the right. So box number 7 is all about writing in interval notation. So what I'm going to do is I'm going to give you 4 examples here. We're going to talk about their graph, and then we're going to talk about how to represent the inequality using interval notation. So the main idea is going to be the stuff that ends up in this column. Okay, so let me move this over just a little bit. Okay, so if I have the first one, x is greater than or equal to 2. So I'd have a graph, okay? I'd have 0, I would have 2, I would put an open dot and then color it in because it's greater than or equal to, and I would shade to the right. Okay, so we want to be able to represent this in an interval. The way that we would represent this interval is we would use bracket 2, comma, infinity, parenthesis. Now the reason we would do this is because we're saying that this line, or this, all numbers that are greater than 2, well, there's an infinite amount of them. So this is going to positive infinity way out here. So we say from 2 to the right, and we go to infinity. Notice that we put the order of the numbers in the same way that we put them on the number line. And the reason we use a bracket here is for the same reason why we colored this in, and for the same reason why we included it here. Because the 2 is included in the interval. So the correct way to write it would be from 2 to infinity. We use a parenthesis around infinity because we can never actually get to the end of infinity, so it would be wrong for us to put a bracket there because that would suggest that we could include it. Let's do this one, this number 2 here. X is less than 5. So here's 0, here is 5. I would put an open dot above it, an open circle, and I would shade to the left. Okay, well think about where this is going, right? This is negative infinity over here to the left. As numbers get really, really small, that's negative infinity, so how do we write this in an interval? Well, again, we read it from left to right, so we'd say from negative infinity, comma, up to the point 5, but we would put a parenthesis on this one because 5 is actually not a member of the interval, because 5 is not strictly less than 5, right? So we do not include it. So we would use a parenthesis. So we use brackets when we include the point, parentheses when we don't. Here's the third one, okay? So this says that 1 is less than x, less than or equal to 7. Here's 0, here's 1, here's 7. Above 1 we have an open dot, above 7 we have a closed dot, and we want the space in between. The way that we would write this in an interval is we would say parenthesis 1, comma, 7, brackets. That's because the 1 is not included in this inequality, but the 7 is included because the dot's colored in. So notice that's in the same order of the number line. 1 is on the left, 7 is on the right. 1's on the left, 7's on the right. It's important to write it in that order. It would be wrong of us to write it like this. 7, comma 1. That would be wrong. We don't want to do that. So we write it in the right order. Last one here. Here's my number line. So here is 0, here's 3, and here's 9. So above the 3, and we closed it in, and we go to the left. We go above the 9, and we don't close it in, and we go to the right. So notice again, this is still negative infinity over here, and this is still positive infinity over here. So this one I'm going to have two inequality, or two intervals. This is going to be from parenthesis negative infinity up to 3, and I would put a bracket on that because I'm choosing to use the bracket because 3 is a part of the interval. Or we would have parenthesis 9 all the way out to positive infinity parenthesis. So we really want you to get good at writing intervals such as these over here on the right. Okay, here's a you try. I want you to write this graph using interval notation. Go ahead and try. Hopefully you got the right answer, but if not, here's how you would do it. Because the negative 3 is not shaded in, I'm going to use a parenthesis. Negative 3, comma, because the 5 is shaded in, I'm going to use a bracket. So this is the correct answer. Negative 3, comma 5, parenthesis on the left, bracket on the right. So the parenthesis matches the open dot, the bracket matches the closed dot. Box number 9, the last box is another you try. How would you write this graph using interval notation? Go ahead and try. Hopefully you got the right answer, but if not, here's how you do it. Remember, this is negative infinity to the left, and this is positive infinity to the right. So I would say from negative infinity, comma, all the way up to negative 1, and I would use a bracket because the negative 1 is part of the solution set. Then I would go from 3, but I would use a parenthesis because it's not part of the solution set, comma, infinity. So this would be your solution.